this one here. Okay, this is the 90 pages script. Okay?
Question. How do we get to this?
Yeah, you will have it. I'll show you. Yeah, I'll show you in a minute. Okay. But this is the one that I would like you to try and complete. It's simple to follow, okay, and it explains everything. Such as...
Is that in the documents folder? The file you are opening on all cloud documents folder?
Yes. Yeah. And it walks you through the preliminaries and even how to load R. But if you don't need, on the platform, you don't need to load it because you have R and RStudio. And it starts with how to find help. Basically, all you have to do is just follow the script here, just the way it is. And it takes you through a lot of the basic material, the basic functions, the basic values, the attributes, and also the types of objects that you have to, you can build. Very simple examples, like here, for example, if you want to remove, you already built, but you want to remove a particular object. How to create any number of things, or use, if you want to use other sources, vectors, how to assign or create a vector. Okay. The vector arithmetics, you can apply. What's a vector? A collection of variables, but they all have the same type, or they call it mode for that matter. Okay. So now, if, for example, you have numbers, then everything should be a number in there. You can add as many or remove specific cells within a vector, but they have to stay the same. List. Who knows what a list is?
It's again, a collection of objects with, in a sequence, in an order, where you can get to the object.
Yeah, there is a structure. A list actually is like a vector, but it doesn't have the restrictions. So in cell 1, you can have a numeric, and then in cell 2, you can have text, and in cell 3, a whole HTTP. The best description, actually, of a list is a web page. Because a web page has massive amount of information, and they all are unique and different, right? Okay? So a list is a combination of anything you want. You can throw into it anything you want. So it could be an image, no, not image, but it can be a combination of things. And then also in here you'll see some of the basic arithmetics, like doing sums and square root and dealing with vectors. Also dealing with missing values. What does a missing value look like, and so on. Anyway, so what we're going to probably focus on, what's a probability distribution?
Assigns probability values to different values of X.
Yeah. How many heard of the bell curve? Okay, that's a probability distribution, except it's really a nicely distributed normal distribution, exactly. And so you're going to be with R, you're going to be dealing with a lot of stuff like that. You know, the distribution of a variable determines how do you approach it, how do you analyze it, how do you apply modeling to it. Okay. Then reading data from files. Remember we started talking about reading data from files? So this is a variety of ways you can, like I said, in RStudio basically you can, let me log in again. Actually I am logged in another place, so let me get out of here. In the environment, basically you can import any set of data, but here it's a little limited in the options, but that's made for the purpose of ensuring these are the most popular, so it's made simpler. Otherwise, one of the first things actually we saw, we have a whole day training about loading data. Okay, we're not going to, but we could spend actually literally the whole day talking about how to load various data. But this is your easiest. A lot of the data that you will get probably in comma separated, and even in comma separated, you can still load text files. You'll just have to change the parameters when you load it. Also, Excel is another popular way of transferring. Companies love to live in Excel. And naturally, the problem is that with Excel is that there are, how many versions of the truth?
Single.
Right.
Yeah, many. There are, even on the same, with the same user, there could be some at home, some at the on the laptop, and some on the desktop, and they go and I'm sure we're all guilty. I did it too as well. I make changes in one and forget that I didn't update in the rest and so on. But to bring in Excel, okay, this is also how you can load the data. This is made simple and easy for you that you can kind of bring in a data set. And once you bring in a data set, remember what we talked about, how do you view it? You just click on it, and it shows you right here. This is the MyLook data set. Okay? So going back to in the own, oh boy, I'm even getting the same. Okay. Okay. So let me go to the material then, and I'll for it looks like it's a virus then. Who is sick this morning? You sure? Come on, let's be honest. All right. Okay, so let me go through the material then. I will just okay, what you're going to see there is at least these two introduction to R and RStudio. In the introduction to R, there are some examples, so let me put it up on. You don't want to see this, right? Okay. Very quickly, what is R and so on, and then some of the things like if you're you're using the R command, basically, these are some ways to get into it. But this explains a little bit some of the types, the basic types of R. Okay. An integer, this is something unique about R, is that for an integer, you have to end the value you're assigning to age 20. If it is an integer, if you want age to be set as a default integer, it has to end with L. Why is that? I think it's something to do with somebody assigning, I guess just a way of assigning. Some people don't like that, I know, but that's just how it is. Okay, L for long stands for. Binary, you can assign binary double, characters, logical, true or false, or T or F. Okay. Now, the one thing that you will notice, you will not use equal, okay, unless you're in brackets and you're assigning arguments. In arguments, equal is what you need to do. Data equal empty cars, for example. But in a normal assignment of value, always use less than and a hyphen or minus. Okay? You can also reverse that. So you can do 20L minus greater than age. So it doesn't care which, you can flip sides. Okay? For those that do have access or do have R, how do you build a function normally, right? So in a function, these are the arguments you want your function to have. So a equal 7, which defaults it to 7, so you don't have to call it, or just a, comma, b, comma, c, comma, d, etc. Right? These are the arguments that you provide when you call the function, and then in this crooked bracket, some people call it squiggly. I don't know, what do you call it? Inside this, you build the logic of the function that you want. Okay? Now, please remember, functions are your friend. Why? Exactly. Reusable. Reusable. Think reusable. You don't have to continuously solve the problem, so you build functions to put in there. Also, like we talked about vectors, right? So, for example, banknotes, C, we assign it 0, 1, 2, 3, etc., whatever we want, and that becomes the vector itself. And if I want to know cell number 5, now let's remember something. In the standard programming, the first index is 0, right? In R, it's 1. Okay, so that's important. In R, the first index is 1. It starts with 1. There's no 0. Okay. So if I want to know number 5, what would that be? 50. Right. Exactly. Okay. Then you want to know the length of banknotes or the mode. The mode naturally is what? The data type, the basic data type. Now, since vectors have to retain the same type, okay, then if it is text, then, it's character, and if it is numeric, then it's numbers. And the same thing here, you can have more than, you can assign a value for each cell, and by assigning the value for the cell given equal George, middle, Walker, family, Bush. And if I want to know given name in a square bracket, given. Okay. Notice that also you have to surround it with, why do you have to surround it with the codes, double quote? Because it's a character. If you don't, then it becomes numeric. Now you can still assign it numeric. But the issue is that if we want to call the numeric cell, the cell number, we don't need codes. But where we give it a character label, then it needs that double code. We're good? Okay. There are some tricks that or ways to try on your own. This is, for example, true, false, true. Right? We said either TRUE capital or T. Right? So this becomes a logical vector. Okay. Try and play around as well with formulas and especially on numeric by multiplications, additions, etc. And you will learn a lot more than I could teach you. What I could teach you, you'll probably forget when you walk out of here. So my best recommendation to you, try it. See what it looks like. And it's not that difficult because you can always, in order to print the value of something, just type the name of it. So if I type C, for example, in this case here, X, then basically it will print TFT. Okay, so a list. We talked about lists. Here's a list. Age is 20L. What did we say? L stands for integer, right? So GPA 3.4, we gave it a numeric, and then the name is John, and married, true, logic, right? Length, names. What are names? Labels. Names or labels. Names of L, the labels. Age, GPA, name, married. Length, of course, is how long it is, and it's a four sets. Right? Okay. Matrices. What's a matrix?
Dimensions, like
Two dimensions. Yeah. Yep. Okay. These are basic arithmetics. Now, a couple of things. A table, everybody knows what a table is, right? In R, we have two types, and that is data frame and a data table. Okay. The data frame is almost the basic standard course inside R. R was made to manipulate data frames. A data frame is a table. If you were to think of Excel spreadsheet, you have the columns and you have the rows, right? Columns up on top, rows, okay? And R uses exactly the same thing. Okay. Now, the difference is columns in R are features or variables, and the rows are observations, okay? What's an observation? An observation is a record of a particular event or a particular situation or a particular person or a climate. So a client, age 34, married, 2 kids, income $70,000, mortgage $135,000, wants to borrow money. He wants to borrow $20,000. Do we give him money or not? So if we were to take that, that's an observation. That's a role. So in data sets, you want to build a prediction. The basic prediction, in the simplest form, is basically built on, do we give him money based on these variables or not? Maybe we'll use the test, the credit score, or maybe some other means of, if they don't have credit score, we built a solution for students. Students don't have credit scores. And so we had to use other means. Okay. Now, the process to do this is basically all based on data frames. Now, the data frames, what's unique about the data frames is that their index is the row number. They have that as a built-in index, and they are sorted by that. You can't resort. If you filter, or you create another object and you filter based on some other means and you sort it, it still is a layer on top of the original, data frame. Okay. Now, that in itself is one of the best advantages of R, because R is so fast and capable at manipulating data frames. Now, if you want to sort by, because it's always sorted by that row number, okay? If you want to change that and actually do some lookup, right? How many people work with lookups? Good number, yes? Okay, so now what you do is that you convert that, or you make a copy of it as a data table, okay? So the other thing, in addition to becoming familiar with data frames, you need to become familiar with data tables. Data tables, they have their own library as well, so look it up and load that data, that library for data tables. And there is a whole topic around how to manipulate that, because now you can sort it by building indexes. It may be the third column and the fifth column that you sort it by, primary, secondary, and it's so fast, it's breathtaking how fast it is that you can do lookup, even if it is single or multiple values that you're trying to do. Okay? It's really, this is one of the unique features of R, is the ability at manipulating these forms at lightning speed, especially applying changes and transformations to data tables and data frames. It's breathtaking. That is the power of R. That's one. You didn't have enough yet? Okay. All right. Control structure. It's no different than, with the if conditions and for and while and repeat and break and switch. Anybody who has done programming, this is almost standard, right? This is, what's a control? For those that haven't done much programming, a control is a way of changing the flow. So, a sequence of transformations or formulas or scripts, it follows a straight line, right? But you can't build a sophisticated logic a lot of times on the basis of a straight line. Sometimes you need to repeat something or make it, if this then go that way, or if that then go that way. You need to do splits and that's what's called control. Okay. So in a control, you have to test for a condition. So what's the condition? A equal B, go this way. Not equal than B, go that way. Okay, so in your building of that logic, or how you solve the problem, is about visualizing your flow, how it moves through the processes and the steps that you build. Okay. Now, some of the most powerful tools in R are this set. Laplace, apply, apply, there's the apply, and a couple of other more features of those. Basically what this does is that if you take a function, let's say a function like we're talking about, mean. You want the mean of all the columns, for example, or all the rows of a specific data frame, okay? You could do if this, then move to the next, or something like that. But that would take a long time. With the Laplace, apply, apply, or apply, you basically run that function so fast, it's beyond belief. And it's like instant, it will spit out the results that you want. So these are very powerful tools. But that's possible because of the data frame and the data table. Questions? I see some people are beginning to, I know, I could talk for hours and hours like that. So some people could be nodding off. Questions?
Are these specific to R?
Yeah.
These Laplace, apply, so are these R specific control structures? Can you call it that?
Yes, they are a kind of part and parcel of the core of R.
Just to improve the speed of the processing?
I mean, that's how they were built, because they were built for the data frames. The data frames are think of them the production engine of R. They are the heart. The power of R actually is because it does everything in memory. So yeah, one of the, I guess, a lot of people point out that, well, you need a lot of memory to run big data. Yes, there are tools also to extend beyond, but if you have enough memory, you load up your whole data set in memory, and you are running through it like, lightning speed. As opposed, you try to do the same thing in SQL or in other languages, and you go to, like we're talking about, if this, then that, or some loop, and you're moving through the rows one at a time, and you're adding this and adding that. You just identify the function you want to apply, and then run Laplace, apply, the appropriate one. Each one of them has its own uses, and it has its own type of output. So become familiar with those. Okay? Now, it is beyond the scope of this today to do that. But like I said, we do have the boot camps if you have an interest in learning how to do that. Environment, yeah, we talked about the environment, right? Hierarchy. This is just an example of the hierarchy, and the purpose of it, if you're calling a function, for example, it goes through that hierarchy to find which one it needs to apply. If you have in two libraries, it's going to go to the one that was loaded first. Okay? Little more about the environment, and then also this walks you through some of the standard. Now, because stats and and data sets are part of the R basic, the R base, when you start R, some of these are automatically loaded. So some of the libraries are automatically loaded. One of those, for example, is stats. So you don't need to go and load the stats library. And that's the richness, one of the richness of the basic R and statistics basically is because of this. Okay. The graphics as well, utilities, GR devices, methods, data sets, auto load, and base. Okay. So these libraries are part and parcel. When you load R, they kind of come in part of the base.
I have a question.
Yeah.
So how does hierarchy work with packages and libraries? So I know some packages have different or competing terminology. Like if you have this one that's already there and you load a new one, which one would take precedence? Would you have to deactivate this one, or would the one that you just added have
These will have, if it is the same function, it will go to these first because they were loaded first, part of the base. Now, if you remember, if you load another, by the way, libraries and packages are one and the same. Okay, it's exactly the same. Libraries are packages, so for that purpose. Now, if let's say we were talking about mean as an example, if mean is part of the stats, which it is, okay. And if another library called RJava, okay. You loaded RJava and it has a function called mean, the default will go to this, not to the RJava. If you want to call the RJava, then you say RJava : mean. Okay. All right. Functions. Yeah, there are some examples about the functions. So basically, like I said, functions are your friend. Build as many of them, reuse them. The other thing I want to show you as well is that once you, okay, let me go on again. Once you're in, you build a function, you can also see it. You can also see it in your environment, because a function is an object, and do I have anything or everything that we have? Okay, environment. Okay, so here's a function, get data. So you click on it and you can actually see it here, what's in it. And see the structure that we just call it, we don't give it any arguments. Otherwise we would have had something in here, right? But since we're not giving it any argument, this is just a straightforward to load up a New York City taxi trips from a, where is it? It's not part of it, but yeah, it loads it from a remote server for a company company in New York. And so we give it the specifications already built in, and that's what it does. It grabs a hold of that data. Okay, other functions here as well. Do we have any more? No? I guess not. Yeah, here's a function. It does nothing, pretty much. It just runs a linear modeling process. That's all it does. Okay, it sends back linear. So the data that we got from that function that calls the remote New York City taxi trips get loaded in here. I'm talking here about the help. Okay, in the help tab, you type LM and it explains it to you, okay, what it is and how to use it. What it does, it fits a model, a regression model, on the data. And it follows this, basically, the majority of these are optional. The most important are basically the formula and the data. So you can forget about the rest if you don't need them. But in that, what the formula is, there are special instructions, and you can use formula equal, or you can just put in a specific script there, and I'll show you quickly. There are examples here. I could run the example, but I wanted to show you here. Okay, so this is the formula. Okay, the formula is that I want to predict the weight using the group as a predictor. That's all. Now, group has already been defined as certain values with labels and so on, and in that there is the TRT, some values there, and so on. So, but if we were to take the empty cars that I was talking about, okay, all I applied was just basically something like this. Let me see if I have empty cars here. No. Okay. So basically, what I will do is that mod 1 LM, okay, and the formula I want to predict the miles per gallon. So MPG, and then I could just put in a dot there, and that means everything else in the empty card. And data equal empty cars. Just that simple. Now, what happens is that it will fit a regression model to that data set. Okay? Now, it's beyond the scope of today to basically put out what the results are and how to evaluate whether that's good or not, is it adequate. Now, the other thing that is important in this also, in regression, it's really based on modeling correlation, right? Now, what's one of the dangers of correlation? Causation. Overfitting is an absolute good second, but observations. What are observations? Observations. Events. Okay. So you take a particular period, okay, and you say in January, Was he a leading man? Yes, no. Was there any number of suicides? Okay. And then basically you build a correlation matrix. Now, we did see a correlation matrix a little earlier. Remember that square, colorful, different sizes? That's one way of presenting correlation matrix. There are many other ways. Okay. So,
Is that what that was? It's truly just a correlation matrix? Nice.
yeah, yeah. It captures the size and the color.
Yeah.
How, how big and small it relates to, and then the color, whether it's positive or negative,
Yeah.
because it could be negative correlation or it could be positive correlation.
Sure.
So let's, I mean, we can quickly do this. So let me do this before I run this here.
Can I ask what the tilde represents?
I'm sorry, what's that?
What the tilde represents?
It represents a separation between, I want to predict this, and the rest are predictors. This is the predicted or outcome. It's called outcome. And the rest are predictors.
Okay.
So the tilde is part of the formula. That's what we said earlier. What's the formula? This is the formula.
Yeah.
Right here. In linear regression, yeah.
Right. Okay.
In linear regression, there are a lot of algorithms that follow the same in how you build your formula, but it's basically an almost. Now, if there are algorithms that use different formulas, they will tell you in their documentation. Where are their documentation? Again, it's in the help, and you can look it up. Now, one differentiation here with the RStudio is that if it is part of the environment, if the library is part of your environment, then you can search for all the functions in that library. You don't have to know the library. Just type in the function or the term you want to use or you want to look for, and it will give it to you. If we have, let's say, ggplot2, for example, is a library. If it isn't loaded, and I want to do a qplot, I go to look for a qplot. It says, I don't know what's that. Why? Because the ggplot2 is not loaded. Okay? Or let's say AES or aesthetic. This is a variable for aesthetic. Something on your mind? You were laughing. Huh.
There's no correlation.
I am relieved.
And causation.
Yeah, so, okay. The other part of that, the richness of R is really in the graphics. So let's go back to that. Yeah. So functions. This is a good primer to use functions, and then editing the data. Okay, you can actually edit the table inside R. So you build the data frame, or you load it up, and you can go and edit it. Probability distribution. Yeah, we were talking about statistics. This is very useful. Okay, these terms are very helpful. If you become familiar with these terms and what they mean, That's a pretty darn good statistics, Brian. Yeah, now, you don't have to know how to calculate them, that's the beauty. So in R, if you want to know what, you know, what the gamma of something, you know, it's built in. You don't have to know how it gets there. You just need to know what gamma is and what the meaning of that value that comes out and how you interpret it. Okay? Any questions? Standard deviation. What's a standard deviation? You don't need to know what a standard deviation is. You just have to STD and in brackets. Put in right? It's that simple. Okay. Now, how would you want to use it? What's important about the standard deviation is that what does it mean? How do you want to use it? Okay. What's 6 sigma?
6.
Variances in the magnitude of 6 times the standard deviation. Right? Right. Okay. Normal variances are within 3 standard deviation from the mean. Okay. Anomalies are outside of that standard deviation, right? Yeah. So if you want to look for anomalies, basically, you know the principle now. The principle is that within the 3 standard deviations variance, that falls within the normal. You may want to change that because of some specific logic, but anomalies would always fall outside of that. So if you have observations for one reason or another, there are variances outside of that, these are anomalies. Okay? How useful is that? Well, anomaly detection. Right? Yeah, you did some R work, right? You had to deal with the anomaly detection? No? What kind of application have you used it for?
I use it in class, we look at some models like
Yeah. Yeah,
and
so
some plots.
in some plots. Great. Yeah, like what I showed you earlier. Some maybe more simplistic. Yeah. Yeah, that's okay. I mean, the power of R also is in the graphics. ggplot2 is one of the richest. There is actually a whole book.
It
The
takes a lot
grammar
of time.
of, pardon me?
It takes a lot of time compared to tablet.
Yeah, it does. But you know what? See,
Tablet
that's why some of what we do is really delightful to us, because when we see the reaction by other people in terms of, man, we learn from you more than we learn from our master's degree and etc. That's basically because we relate it to something we can use. We explain, for example, in the layers. Once you understand the layers in graphics and how each one of them and how to stack them and build them on top of each other, it becomes like, wow, neat. I can learn to like this. But it's challenging because you could spend, actually there is a book about the grammar of graphics. It's called The Grammar of Graphics. Like, you know, if you grew up here and you learn all the grammar you needed in school, what the hell do you need the graphics grammar for? Right? But it does. This is probably the latter part of R starts going into Distribution, back to the distribution and what it means, okay, and how to plot this. Now this is kind of starts getting us into the plots, right? Now this ugly looking plot is about the eruptions and yeah, the eruptions. This is a data set that exists inside R. There are a number of data sets. Now mind you, the data sets that exist inside R are standard across. They aren't unique to R. Some of them have been used by mathematicians and statisticians for a couple of hundred years. One of those that everybody probably that goes and does R is called IRIS. And the IRIS, you know it? Yeah, the IRIS data set is a measurements of the three types of irises, a measurement of their petal length, width, and sepal length and width. Okay. And from that, you predict what type it is. So what do we have? There is about 300 observations, and they are scored what type it is. So now, the process of getting there is basic. This is the process of building a predictive model. The business motivation. What are you trying to solve? Now that is significant because in a lot of times in all the academic teachings, this is the poorest taught because it's almost non-existent, or it doesn't. Now, mind you, that's not just it's also a subject matter expertise. Okay. Your experience outside of, other than R, in your business, what is it? And the company you work for, in what domain?
Real estate.
Real estate. Okay. See, that's a very rich domain that requires a lot of subject matter expertise. Understanding, for example, valuations. If you want to predict the value of a house, you need to know something about the structure of the house, the market, the business, the real estate business, the taxation, any number of these things. And going through a master's degree is not particularly, they aren't going to teach you in analytics, they aren't going to teach you real estate. But that's just one. What is needed is to be able to understand what the business problem that you're trying to solve. You need that subject matter expertise. Or you bring in somebody that can help you at identifying what do we want to solve? What are the drivers of that solution? So you want to make more money by maximizing the price of the house. Well, what are the drivers? Do we just grab observations out of a hat? Or do we identify those drivers that could contribute into the price of the house? Maybe that's not what you want to solve. Maybe you want to solve, why aren't we making more money from the Buckhead market as opposed to, Sandy Spring market? So what are the drivers? How do you translate that business objective into some data that then you can put together and use? You go through that data discovery, that's the discovery of the data, descriptive and exploratory analytics. And you may have to go back and join data to enrich the data itself. You redesign the data. Now in some of the machine learning, some of that stuff could, not the machine learning, and deep learning, there could be some of that. But also, you have to be able to do that and understand how to do that. Reshaping of the data to maximize the value you can. So in the case of the iris that we were talking about, that data existed 200 years ago, 200 plus, since the 1700, 1740 or something like that, that it was collected. It's clean, it's so tidy. Now, how many of you work with server logs or web logs? How clean are they?
Not very.
Raw data doesn't look like anything like a structured data. We're going to take a look at that iris data set and look how clean it is. Real live data doesn't look anything like that. Okay. How many people work with CRMs? How good, how accurate is the data? Barbaric, right? Yeah. So you get, let's say you want to predict who's going to churn and who doesn't. The data is filthy, dirty, so we have to realign, clean it up, restructure it, tidy it, not just in terms of tidying, not just in terms of the value, the values that exist, which you could have names and phone numbers and names and etc. Right? But to prepare it to such a level that it really is tight in terms of, you could have a couple of hundred variables in a CRM, right? Yeah, that's not unusual. But you don't need the 200 or a couple of hundred. You probably need at best maybe about 20 to 30 values. Sometime you actually re-engineer some of these to kind of bring them back into, eliminate correlation between them, because correlation between them could cause confounding of the predictions. Okay. You could bias the predictions. Now you get into building your predictive model. You set your data how you want to sample it. There's training, test, cross-validation, etc. And you build the models, not one, many models, because you're going to try maybe linear regression, maybe logistic regression, etc. And you compare them. You compare the results, and that's where testing, the testing validation is a process not done by just one person. You would want to have at least another analyst or somebody else look at that and say, yeah, we accepted this instead of that model because X. Or you could actually end up building an ensemble of models, multiple models in a certain configuration or formation, because one particular model does not respond well to the data. A second model, and in parallel or some weighting assigned to them, etc. You build your model. Now, then, you go back and cross-check with the business. Ask the business, the guy who wrote the check for that project, a couple of $100,000, he wants to know he's going to get his money back, right? Now you need to actually explain it in business terms. How does it solve that problem, and what are the business implications? If we flip a coin, what's the chance of a head? 50, right? 50-50. So if your prediction is accurate 60% of the time, is that good?
Yes.
It's not. Because that's a lot of money gone on building a solution that is not adequate enough. Why is it not adequate enough? Let's think about false positives and false negatives. Okay. So if you predict wrong, what does that mean in a churn? Mark is going to churn. You predicted him wrong that he's going to stay. That's a lost opportunity. You gave your boss or the company a false sense of security that, oh yeah, he's going to stay. No, he went. The other way, you predicted Greg, right? Okay. We predicted that Greg is going to leave, but he was going to stay. Okay? What happened? We offered him $200 package. That's pretty solid for him. Okay? So, you see, when you look at it from that financial perspective, it changes the value proposition of your prediction. So 60% becomes like, whoa, we're going to miss a whole lot.
Or you could look at it like if you were predicting horse race, okay, 60% probably.
Might as well go to the horse race or flip a coin.
That's what I was thinking, like one of the
Yeah.
Vegas.
I doubt it somehow that business.
You're making good money.
Yeah.
Yeah, I doubt it somehow that business executives would like the idea of going to the race. If anything, they don't. They want to know, they want to make their money back, right? Yeah. So even 70 and 72 and 75% is kind of... Now, you may still do it. They may still say, okay, well, let's do it as a first step and learn from it. And we may be enriching the data in the next year, and then we come back next year and improve it. Now that's their decision now, because it's their money, right? It's their money. Here's another problem. You may end up that the data solves somebody else's problem, not the executive, but his competitor on the opposite side of the aisle. And he's going to kill you because you did that. Okay? So, the data may not contain necessarily the decision that, the support for the decision.
Are there libraries for R, like there would be, let's say, in Python for true machine learning and into neural nets for nonlinear regression? So
Oh,
there
yeah.
are, okay, good.
Yeah. Oh, yeah. There are.
Access to
Now, just so happened that a number of these deep learning tools that came in lately, such as TensorFlow and Theano and Keras, and they are built in Python, which is, there's nothing wrong with that. In fact, like we're talking about, you can, I ran some scripts to call TensorFlow and make use of it. There's nothing wrong with doing it that way. Because ultimately, that's why the platform, I hope it worked. I would have liked to have shown you for some reason, I'm not sure why the engineer didn't come today. But one of the things that we did is that we have the Jupyter with Python 2 and Python 3 and Scala and other tools, and RStudio, and MySQL and Postgres built in the platform that you can for teams to work together to be able to build a solution, because the reality is that there are three main skills that are going to be needed and are in hot demand. The three main skills, aside from all the noise about HTML and Java and C++ and all of that, the three main skills are consistently Python, RStudio, and SQL. Okay. SQL, because most of the data sits in SQL-based type of data. even all that noise that was made about the NoSQL in Hadoop and all of that,
When you're saying Python and R, are you saying and or are you implying or?
and,
And.
yeah. Yeah, the demand actually for all three.
So you have to know both Python and
Well, you don't have to, but it's really dependent on how the company, how strict the company is on that. And there are plenty of demands, plenty of jobs out there for these skills. Okay? But to solve your problem, one is enough. You don't have to. But to solve significant amount of these problems, yeah. Okay? Now, more than anything else is that, yeah,
Yeah, when you just said, the skills, you said R, Python, and,
SQL.
what's it? And SQL. Well, I mean, where do the R programmers hang out online? Because when I go to Stack Overflow, I mean, that's where most of the programmers hang out, Stack Overflow.
yeah.
I mean, I see Python up there, but I don't see R. I mean, I guess I'm asking, my question is, where do the R programmers hang out online?
There is in Stack Overflow, there is a massive amount of questions answered on there. That's where I look first.
Okay, but like,
Stack
I mean,
Overflow.
I
But
guess,
there
I guess
are-
Stack Overflow, they trend like what languages, based on the chatter. And it's like Angular, JavaScript, and then Python, is like 5th or 6th. But I never see R. I mean, is it a big ecosystem out there?
Yeah,
that I don't
there
know
is
about?
also on Google, there are on their ecosystem, there is a lot there. There are a lot of if you look, let me show you how quickly you can find answers for them.
I would say